For the first half of this section, so what we did in our previous lesson here, we just centered the hyperbolas at the origin, 0, 0. So now we're going to talk about what happens if we move the hyperbola away from the origin, like we did with the ellipse. Like we started at the origin for the ellipse, then we talked about what does it look like if we move it away from the origin to a different point. So now we're going to do that same thing here today with these hyperbolas. So we're going to talk today about how do we handle these hyperbolas when they're not centered at the origin. And we'll also see a little bit of having to rewrite some of our equations with completing the square again. We saw that as well with our ellipses. Like we had that whole second section of 7.1 that was just dedicated to writing out using completing the square. These two charts, we had charts like this as well for our ellipses, but they're very similar to what we talked about in the past. They have a lot of information on them as far as how to graph things when they're put not at the center, 0, 0. Remember, what you're going to do is look at the numbers that are attached to the x and to the y, and you always take the opposite sign when you're pulling your center. You could still think about your parent graph to help you graph these, just like we did with the ellipse. So if you want to graph the original hyperbola, you can. You could also just think about what your A and your B would be, and if does that mean I go up and down this many or left or right this many, and then just move your center, and then just from that new center go the same directions that you know you would have to go from your parent graph. So you don't have to graph everything. You can just think about some of those things mentally if that makes sense to you. So we're going to kind of skip over that. I'm not going to get into too much of that there. You can read through it yourself. But I'm going to look at the next page here, and we're going to start doing some examples. Like I said, this is when we're going to start to see the completing the square process show up again. They're giving me an equation that looks like this to start with. It's not written at all in the standard form. It's not written where I can identify the center, I can identify my a squared, b squared, all that stuff. So I need to do a little bit of work. When we did this in the past, remember our first step was to regroup terms. So put your x's together, put your y's together, and move that regular number over to the other side. So they put, I'm just going to highlight our like terms here. They put the 4x squared and the negative 24x, those are right down here. So they just kind of drop down below. The y's right here, those got dropped down. And then this negative 153 is now over on the other side. So see how it becomes a positive 153 because we added it over. What they did second here is they noticed that the number in front of an x squared and the y squared is not a 1. And it would be easiest if it was when we're completing the square. So they took this 4 out. So they put that in the front. When you take it out, though, you have to take it out of all the terms. So when they took it out of the 24, that's how they got the 6. They did the same thing over here with the negative 9. They took the negative 9 out of the equation. When they do that to the negative 90, that's how we get the 10 there. So that's where those numbers are coming from. And then also notice on the other side with the 153, we saw this happen when we did ellipses as well. Those numbers that we factored out are now going to sit in front of the pieces that we're putting in the blanks. Now, they kind of skipped over the blank process and how to get these numbers. So let's talk about where this 9 came from here and where this 25 came from, because we see them over here as well. Do you guys remember what you're supposed to do when you complete the square? Yeah, take half of the middle term. So on this first one, the middle term is the negative 6. So half of negative 6 is negative 3. And if you square that, that's where you get 9 from. And then the next one, the middle term is 10. Half of 10 is 5. 5 squared is 25. So that's where those numbers are coming from. Now down below, they're starting to factor it. We're slowly working our way towards our form for our hyperbola. How they got that first quantity that says x minus 3, when you took half of negative 6, we got negative 3. So that's where it came from. The other thing you can think of is two numbers that multiply to the 9 and add to negative 6. Well, it'd be negative 3 and negative 3. Since it's the same quantity, we just write it one time. Everything is squared. Same thing happened on the y section. Two numbers that multiply to 25 add to 10 would be 5 and 5. So that's where this 5 comes from. And then all they did over on the right side is they just kind of started to simplify those numbers. So they multiplied the 4 and the negative 9, and then they added them all together, and we're left here with this negative 36. Now, I want to get that 36 at the end to be a 1, because remember when it's in an ellipse form or a hyperbola form, the standard form says that the following number at the very end should be a 1. So they're dividing everything by negative 36. Because we're dividing by a negative, we will want to watch our signs here. 4 over the negative 36 is going to reduce to negative 1 over 9. And then the negative 9 over the negative 36 will reduce to 1 over a positive 4. So keep track that these signs are kind of switching here because we're dividing by a negative. Now, when we have this happen, especially like even from the beginning, when you're trying to write it out as a hyperbola, we talked on Friday that writing a hyperbola, it's really important that you know what term comes first because there's always a minus sign. We can't just rewrite that however we feel because the minus sign is going to really dictate what's going on. So when you're looking at the original equation, if you're trying to figure out like, well, how do I know what goes first, the x or the y? Well, the positive term is always going to come first. So in this case, when they wrote it down here, that first piece has the negative in front of it, the one with the x. So that's actually in the wrong spot. The y has the plus sign in front of it. So I need to just flip those around to get the positive term to come first. And that's what they're doing here, is they're just rearranging so that that positive term is in front. So the y piece comes first, and then it now says minus the x piece. So if you're ever getting to that point and you're like, well, how do I know what goes first so that I know if it's a vertical, major, vertical, horizontal? The positive term is always going to go first. Now, if you look at what's written there, my center, and be really careful with this because it is written backwards from what you guys need to think. The number with the x is the negative 3. So you're going to pull out the 3, and then you're going to take this negative 5. But make sure when you write them down here that you do still think about order of a coordinate. Coordinates are not going to be affected by how those hyperbola equations are written. So the x always comes first and the y always comes second. Now, when my equation was written here, it's backwards. So it's really easy to make the mistake and just grab negative 5 and 3 and try to write your center like that. So make sure you're paying attention. Where's the x, where's the y? The x has to come first, then the y, but still changing their signs. We're still going to do that. Then we can find our a and our b. Remember, a is always the larger of the two numbers on a hyperbola, so the 9 is your a squared term. So the square root of that is a 3. That's where that came from. The b squared then would be the 4. The square root of 4 is 2, so that's where that came from. And then they're showing you how they solve for c squared, which we did a little bit of that on our bell ringer today. You're adding your a squared and your b squared, so 4 plus 9 is 13. And then we got a square root 13. What is that about? 3 point what is the square root of 13? 3.6. Okay, so now we're going to actually get into graphing. We've got our center, we've got our A or B, we've got our C, so now we should be able to start to think about how we're going to graph this here. Like I said, you can start with the parent, you can pretend like this is centered at the origin again if you'd like to, and graph your hyperbola, and then just move all your points. Instead of doing all of that though, I'm going to focus on moving my center and then thinking about what direction would my A and my B go from my center, and then I'm just going to count. And it would still end in the same spot, even if I did start with the parent graph and I moved everything. So my center is at 3, negative 5. So coming down here to my graph, I'm going to put that point on here. So 3, negative 5 would be here. Okay, so that's my new center. Now, if you think about your original equation up here, because the y comes first, because of this coming first, this means we're dealing with a major vertical graph, which means that the branches are going to open up and down because they're going to be along your y-axis. That's all going to come from your A term. I'm sorry, the number underneath it, your B term. So the B is going to be the 2. So from the center, I'm going to use this because that's what fell underneath the y, and that's what's going to tell me I go up and down. So I'm going to go up and down from my new center, 2. These are my new vertices. Now the A term, because that's on your X, that tells you what you would go left or right. But remember I said we don't We don't really need to graph those points, but you could if you wanted to. So you would just go left and right 3. Okay, now my branches are going to come off of these 2 points here because like I said, it's going to open up and it's going to open down. But I need those asymptotes drawn in so that I can figure out how big of a branch should I make. I don't want to make it too big. I also don't want to make it too small. So I need to think about those asymptotes. Since the y came first, just like what we talked about on our bell ringer today, since the y comes first, you put your b over your a term. So they're getting the 2 from the b and the 3 from the a to write out my equation down here, 2 over 3. So from your center, you're going to go all those combinations of 2 and 3, like up 2 and right 3, up 2 and left 3, down 2, and then right and left 3 as well to get your 4 corners. So I'm going to do that here. Okay, so those red dots that I have on my graph right now, those would be the 4 corners of my asymptote. Now, it just looks like all I'm doing is drawing a lot of dots here. I want to start to get these asymptotes drawn in. So remember, they go through the center, and they're just dashed lines connecting those 4 corners. And then you should be able to draw your branches. They're going to come off of these vertices that are up and down from the center. So I'm going to go like this, keeping them inside of those asymptotes. And again, sometimes you'll see people draw in the box here. And that's maybe where those other points that we had, the A went over left and right 3, they should kind of line up in that box that we're working with there. And then the only other thing that I would want to see is your foci. So that's your C value. We said that one was at 3.6. So from the center, because my vertices go up and down, I need to go up and down 3.6 as well. So you just need those extra points there. So I like to go about it that way. I think that's a little bit faster than having to graph your parent and then move everything. If I can just think about what direction some of those points would go, it's a little bit easier than the ellipse. Sometimes the ellipse, you kind of need that parent graph so you can really see where all the vertices are at. And then you're just moving these things. Okay, so let's do another one here. So let's turn our page over. Okay, so we're going to start this from scratch here. The first thing we need to do is write out our equation. So we have to do our completing the square process here. So let's begin with that. So I'm going to start by rewriting it. What should I be grouping together? Yeah, the x and the y. So 4x squared and the 32x should go together. And I'm going to go ahead and just draw in my blanks here as well. And then my y's need to go together as well. And then remember, we want to move that 39 over to the other side. So we're going to do that. It's going to become negative 39 now. And then we need 2 blanks that follow that number. From my first set, can we take a 4 out of the 2 terms? If we do, what is 32 divided by 4? 8. I'm going to go ahead over here. That's going to mean I need to put a 4 in front of my first blank to represent what I just did there. Now in the middle, there's not maybe like a 2 or a 3 or a 4 that we can take out, but I do see a negative there. It'd be nice if we could get that negative out of the way. So if I take a negative 1 out, that would make the y squared become positive. What happens to the 6y? It's going to become negative. So when you take it out, I'm only doing that to make that y squared positive because I'm going to want the y squared to be not having a -1 in front of it. But then I got to make sure I reflect it on my y as well. Okay, and then down here, we need to make sure that we have a -1 in front of this second blank here. Like that. Okay, now we can start our completing the square process. So going to our first set of parentheses, what's half of 8? 4, and 4 squared is 16. So 16 is going to go here, and it's going to go here. And I'll just write what we did here underneath. 8 divided by 2 squared. Over here, we're going to do the same thing. -6 divided by 2 squared is 9. So that goes here and here. Okay. On the first set, what two numbers do this to factor it? What two numbers multiply to 16, add to 8? Should be the same number, right? So 4 and 4 should always be the same number for these. So 4 times 4 is 16. 4 plus 4 is 8. So it's going to be x plus 4. Okay, and then this is a -1 here. So minus y. And then what numbers are going to, same number again, is going to multiply to 9, add to -6. Yeah, -3, -3. So I'm going to write y minus 3 squared. Okay, we're getting closer. Now over on the other side, let's simplify all of that. There's a lot of numbers happening there. You've got -39 plus 4 times a 16, and then you got a -1 times 9. What does that all come out to be? What did you get, Daisy? 16. It is 16. It is 16. Okay. All right, now I want it to equal 1. So I'm almost there. I'm almost ready to start thinking about the graph. I need to get rid of that 16 and make it a 1. So we're going to do that by dividing by 16 on everything. 4 over 16, how does that reduce? 4. So it'd be x plus 4 squared all over 4 minus, I can't really do anything with the second half, so it's going to say y minus 3 squared over a 16, and then equals 1. Is the positive term first? Yeah, the minus sign is in the middle. That's where we want it to be. So I don't have to worry about switching this one at all because it's already in front of the y squared. So it's written the way I would want it to be written. Now let's start to pull our information. Because the x comes first, this tells me that it's going to be major horizontal. Okay, all because of this x being the first term. That's how I know it's a major horizontal. Okay, let's think about our center. Where would my new center be? Good, -4, 3. This time, you could just grab the numbers like you see them because x comes first, y is second. So we want to make sure that we just grab those numbers as is. If the y had come first, you'd have to be a little careful with that center. Okay, my a squared always comes underneath the first term. So a squared is going to be the 4. So what's just a? Oh, I wrote that wrong. That's my b. Yep, I said that wrong. B squared is always the smaller of the two. So a squared should be 16. So a is 4. Let's go ahead and find c squared while we're here. And we'll do our asymptotes as well. And then we'll go to the graph and do it all in one big swoop here. So c squared would be to add 4 plus 16, which is 20. So what's just c? 4.4? Okay, so let's round it to 4.5. Okay, and then let's talk about the asymptotes. So asymptotes, because the x comes first, if you need to, we wrote this on our very first page, okay? And I still have to go back sometimes and look at it because I forget. But x squared is always the b over the a when the x comes first. So the b we said was 2, and the a was 4. So 2 over 4 is like your asymptote. Sometimes they'll write it like this, y equals 2/4 x, or you could even think of that as 1/2 x. We should have everything we need to go and graph it now. I'm going to start at my center. So -4, 3 is my center. Now, because it's a major horizontal, that means it's going to open up left or right. Okay, and that's based off of the 4 that's underneath it. So we're going to go left and right. Oops. Okay. You could go the other direction if you want, just to kind of get an idea of where this box is going to be at. And then for my asymptotes, we've got 2 over 4x. So from the center, you're going up 2 and over 4 in all these different directions to get those lines drawn in here. You can draw that box in. It's all right. And then we're going to draw those branches in. They should stay within the asymptote lines. And I think the only other thing that we need here is to graph the C point, which is at 4.5. So it's just a little bit farther than those vertices there. All right, any questions on our hyperbola? Okay. Okay, let's go back. Let's fix this. Yeah, since we read this wrong. It's just going to change a couple things. Wow. I know, I'm sorry. I read it wrong. I did. I read it wrong. So my a squared always comes first. So actually your a squared should have been a 4. So your a is 2. The b squared would be 16. So your b would be 4. So that is going to change our graph a little bit. The c should not be affected. The asymptote should not be affected. But my graph is going to need to change here a little bit. So my center is still going to be at -4, 3. But this time, because the 4 is underneath the A, you have to go left and right 2. I was reading it backwards. And then the other ones would be going up and down 4. And then if you do your 2 over 4, oh no, that has to switch upside down too. So it should be 4 over 2. Because we switched our A and B. So you're going to go up 4 and then left and right 2, down 4, left and right 2. Then you can draw that box in if you want. The branches then should still be opening up left and right. And then the C is 1, 2, 3, 4.5 still. So like that. I'm glad you caught that. Thank you for telling me. So that's what it should look like. I just got my A and B mixed up, and then that affected my graph. So don't make that same mistake that I just made. Be better than me.
People are gonna like watch the video, do the first one, and then just like, stop it and complete it.
I'll have to make a little note in my video of like, don't stop because I make a mistake.
Don't stop on the last problem.
Okay, that should fix it.